Good evening, everyone. So this evening, we're working on factorization. Remember, there are four main types of factorization. There's HCF, there's factorized by grouping, there's quadratic factorization, and then there's our difference between two squares. Now, you have to be able to know how to interpret which is which. Now, factorizing by grouping, you know it's a factorizing by grouping if you have four terms, right? So once you have four terms, all separated by either an addition or subtraction, you know you have to factorize by grouping. If you have an expression and it's in the form of ax squared plus bx plus c, a, b, and c are constants, meaning, well, not constants, but they are any number, they could be any number, and x could be any letter. And then the difference between two squares, if you have something that is squared minus something else that is a perfect square. And if it's not one of these, then you know it's HCF. So it's like you're doing a method of elimination. So let's look at the first one. They gave you 6y squared minus 18xy. So when you look at it, 6 is not a perfect square. Neither is this a perfect square. So you know, although it's a subtraction, it is not a difference between two squares. It is not in the form of ax squared plus bx plus c. Although there's a y squared here, there's only two terms. So you know it's not a quadratic. It's only two terms. So you know it's not a factorized by grouping. So by method of elimination, we know it's HCF. So we have to apply factorization by the highest common factor. And you remember your steps. Remember, look at the numbers, you pull out the highest in common. That could divide into each of them without leaving a remainder. So that will be 6. Y is in common in both terms, so we pull out the one with the lower power. Whatever we pull out, that is known as your HCF. We're going to divide that into each of our terms. So 6 could go into 6 once, y could go into y squared, y times. So from the first one, we just have 1y or 1. 6 could go into 18 3 times, and the y will cancel with the y. So we're left with 3x. And that's it. That's 2 marks. Right? 2 marks for that one. That's all. So you just show your working and that's it. You don't have to show this part. This part up here is just for your general knowledge as to how to interpret with, right? So you don't have to tell them that you're factorizing by grouping or different between two squares, you just do it. Next one, number 2. They gave us 4m squared minus 1. Now, anytime you're minusing, your first go-to is to check and see if it's a difference between two squares. Remember, not all the time would it be a difference between two squares once you see a subtraction sign. This must be a perfect square, and this must be a perfect square for you to apply that one. So 4 is a perfect square because 4 is actually 2 squared. So if I have 2m all squared, right? Because 2, like if you pull out a square, everything inside the brackets will be squared. So 2 squared is 4, m squared is m squared. So you know that's a perfect square. 1 is a perfect square because 1 is 1. 1 squared is 1. And a lot of students, they miss that fact, that 1 is a perfect square. So once it's a difference between two squares, we perform that factorization. So anytime you have a difference between two squares, you take the first term minus the second term, and then the first term add the second term. What if we do the other way and add them first and then subtract? That's okay, right? You still get it. And that's, once you do this, you get 1 now. Right, so part 3. For part 3, they gave us 2t squared minus 3t minus 2. Now this one is for 2. Now, by method of elimination, you could look at it and you could see that it's a quadratic, right? It's in the format of a quadratic. It's just instead of x, they have t. And you could use any letter. So, quadratic factorization. Your first step is you're going to multiply your c by your a, right? So you can put it into the form of ax squared plus bx plus c, where you know a would be positive 2. Remember, your sign is also very important. B is the number in front of x, or in this case t, which is negative 3. And c is the number that is not attached to the letter. So in this case, it is negative 2. So remember your steps. It takes some practice, but once you continuously practice it, it sticks after a while. So we're going to multiply b by c. So that will be negative 2 by 2. When we multiply negative by 2, don't forget your signs, very important. We get negative 4. Anytime we're adding, right, so we want to find two numbers, which when multiplied will give us negative 4, and which when added or subtracted, because remember, you can add a negative number, which makes it to subtract. It becomes negative 3. So we are looking out for two numbers, which when we multiply will give us negative 5, negative 4, and when we add them, we get negative 3. So your first step is to look and see all the ways I could multiply to get 4. I can multiply 1 times 4, and I can multiply 2 by 2. Now, if I use the second one, 2 by 2, if I add them, I'll get 4. And if I minus them, I'll get 0. So you know it's not this one. So it means, therefore, that it has of numbers. Now, we are looking for 2 numbers. So we know it's 1 and 4, but we want it to be -4. And when we add them or subtract them, we get -3. Now, in order for them to be negative when we multiply, one of them must be negative. Which one will be negative? You have to go back to your rules with positive and negative numbers. The rule is when you have, so we know both of them has to be different signs in order to get -4 when you multiply, right? Because remember, when you multiply like normal. But if you have 2 different signs, my answer will be negative. So that means one of these will be negative. In order for them to add or subtract, and this to be negative, it meant that the bigger number was negative. Because remember the rule, when adding and subtracting, if you have 2 different signs, we subtract and keep the sign of the bigger number. Therefore, the bigger number had to be negative. So that means the 2 numbers would have been +1 and -4. So that when I multiply the 2 of them, we got -4. And when I added them, watch this, I have +1, add -4. These 2 are different signs back to back, so we replace it with a minus sign. So 1 minus 4, subtract, keep the sign a bit bigger, we get -3. So we know that our answers will be -4 and +1. Pausing here. Right, so we found the 2 numbers that will be used to expand the middle term. So remember, in your quadratic, the first term stays as is, but the second term will be broken up using the 2 numbers that we just got. So first one stays as is, second one we break it up. It doesn't matter which one, right? So I have 1 and -4. I don't have to put the 1 because it's understood. Right? It doesn't matter. I could have put the 1t first and then -4. Then we're going to factorize by grouping, right? Look at the numbers. The HCF of 2 and 4 is 2. I have t in common, so I pull out the one with the lower power. Whatever we pull out, we're going to divide each term by it. 2 could go into 2 ones. T will cancel into t squared, t times. So I'll be left with t. 2 could go into 4 2 times. T will cancel out with t. So I'll have this. We're going to copy what's in the brackets and paste. Ask yourself, what would I multiply by out here to get back the last 2 terms? And in that case, it's exactly the same. So if I want to get back exactly the same thing, I'll just multiply by +1. I pull out one of the duplicated terms, and then everything else, I'll put it together in the other. All right, so algebra and fraction. Now, basically, anytime it's written whereby you have a number on top as well as one below, or an expression on top and below, we treat it as fractions, right? So in a case like this, anytime we have to simplify, remember, anytime we're simplifying, there's no equal sign, right? So we look at the ones with simplifying, and then we look at the ones with solving. So anytime you're simplifying, it means that we are simplifying expressions, which means no equal sign is given. If we have to have an equation and there is an equal sign, then we solve it. So they told us to simplify this and write it as a single fraction. Anytime we have a fraction plus or minus another fraction, and it asks us to simplify it, apply your regular rules when it comes to fractions. Now, in this case, it comes like we are subtracting two fractions. When we're subtracting two fractions, when you're adding or subtracting, we could only add or subtract if my denominators are the same. So let's go back to a regular fraction. Let's subtract it firstly. In order to subtract the fractions, I'm just going back to the foundation. The only way we could subtract fractions is if the denominators are the same. If the numbers below or the denominators are not the same, we have to find the LCM. If you have trouble finding LCM, LCM means lowest common multiple, which is basically for each of the numbers, you're looking at the timetable, right? And you're looking for the lowest number that is in common, which is actually multiples of the timetable. So like for this one, we have 2, 4, 6, 8, 3 times, so 3, 6, 9. So the lowest in common is 6. Now we don't have to show that. They expect that we know it. But in case you didn't, that's what we do to find it. So the LCM of 2 and 3 will be 6. You have to make each of them 6. So ask yourself, what would I multiply 2 by to make it 6? I'll multiply by 3. Whatever I do to the bottom to make this 6, I must do it to the top. So if I multiply 3 to make this number 6, I must do it to the top as well. Whatever I do to the bottom to make this 6, 3 times 2 will be 6. I must do it to the top. And then we just solve it. So 1, 3 is 3 over 3 2s are 6. 1, 2 is 2 over 3 2s are 6. Once my denominators are the same, my denominator stays the same, and then I just subtract the numerator. So basically, that foundation in fractions is what we're applying here. I cannot subtract these two just like that because my denominators are different. So in order to be able to, I have to make them the same by finding the LCM. The LCM of 3 and 4 will be 12. If you didn't know it, just look at the times table of 3 and 4 and look for the lowest, the first one that will be in common. Ask yourself, what do I multiply by 3 in order to make 12? I'll multiply 4. But whatever I do to the bottom, I must do it to the top. But remember, the top is an expression. So everything in that expression must be multiplied by 4. Whatever I do to the bottom here to make it 12, I must do it to the top. So everything up here must be multiplied by 3 as well. So this becomes 4 times everything here. Anytime you have brackets, this could have been in front of here, right? If you put it in front, if you put it behind, it's the same thing it states. You have to multiply whatever's outside the bracket, immediately outside, by everything inside. So 5p times 4, 5 4s are 20p. 4 2s, that's 8. Over 4 3s are 12. 3p minus 1 times 3 3s are 9p. Minus 1 3 is 3 all over 12. Now my denominators are the same. My denominator stays the same. And now I could subtract the numerators. So we'll end up with 20p plus 8 minus, now look at this, it's minus all of them. Right? So the mere factor minus in here, there's a sign plane here. So this here is actually, I have to open up this bracket here. Right? This is happening because there's a negative sign out here. So it's negative times everything inside of here. So we have negative 1 by 9p, which will be minus 9p. And then minus 1 by minus 3 becomes positive 3. Think of algebra as a very organized individual. So you see how you have P over here and P over there. Here no P, there no P. Everything just scattered. Algebra likes you to organize everything. So it wants you to bring all the P's together. So we'll bring all the P's together. So that will be 20p minus 9p. So if I have 20 pence minus 9 pence, so 20 minus 9, I got positive 11 pence. So 11p. Remember, you could shuffle them around once you've moved them with the sign that is in front of them. And then 8 plus 3, 8 plus 3, 8, 9, 10, 11, will be positive 11 over 12. Now, I cannot add this any further, right? Because they are 2 different terms. That's like adding pens to erasers. It's 2 different things, so I can't add them all together. So that's the furthest we can go. And it did say as a single fraction. This is a single fraction. Before it was 2, but now we have 1. All right, so let's take a look at this one. This one is coming from the May 2024 past paper. So again, it's an algebraic sum. Now let's take a look at this one. Laura needs to put mesh around 2 seed beds to protect her seedlings. Although she uses 60 meters of mesh, altogether she uses 60 meters of mesh. One of the seed beds forms a rectangle and the other forms a square as shown below. The width of the rectangle is x meters and the length of the rectangle is 3 times its width, right? So basically, if the width was x and it said that the length is 3 times that, then it will be 3 times x. Right? So it's going to be 3 times x. Right? So if it is that the width is x and the length is 3 times the width. If the width is x, then the length will be 3x. The length of a side of the square bed is y meters. It says, using this information, they want us to derive a simplified expression in y in terms of x. All right, so far we know that the length of the rectangular seabed is 3x and the width of it is x. Now, the length of the seedbed that is square in shape is y. So this here is the rectangular and this is the square. Now, if all together the total mesh she used was 60 meters, it means that the length of all of these right or wrong to block off the seedbed has to be 60 meters. So what we can do is we could find the distance around the rectangular one and the distance around the square bed, seed bed, which is basically you're finding the perimeter. So we could find the perimeter of the rectangular seed bed, and when I add it to the perimeter of the square seed bed, it must be 60 meters in total. So the perimeter is basically you add up all the sides around. So that would be, if this is 3x, here is 3x. If here is x, here is x. So the perimeter of this will be 3x. You can either say length by 2 plus width by 2, or you just simply add all the sides together. And when I add the perimeter of the square, so if this is y, this is y, this is y, this is y, then the perimeter, the distance around, will be y plus y plus y plus y, or 4 times y. So we'll end up with 3x plus 3x. That's like 3 mangoes plus 3 mangoes, that's 6 mangoes. If there's no number in front, we understand it's 1. So that's 6 at 4, sorry, 6 at 2, which is 8x. Plus 4y is equal to 60 meters. Now, they asked you for it in y, in terms of x. Anytime they give you something like this, where they say one variable in terms of the other, it means that that first variable has to be alone on one side of the equal sign, and then the other variable will be on the other side. Right? So that means we want to put y on one side, so basically making y the subject, and then x will be on the other side. All right? So we're going to carry everything across, and once you do, it's going to do the opposite operation. So this term here was added, so when it goes across, the opposite of adding becomes subtracting, right? I'm taking off the m because that m simply means meters, right? So we're removing the m. So when I carry this across, we get negative 8x plus 60, right? So we remove the meters, which is basically the units. Now this said simplified expression. Now we could break that down more, but we could break that down some more because I could make y the subject alone. So that means to get rid of this 4, I could carry it across. It was multiplying. So when it goes across, you're going to do the opposite operation, which will be dividing. So it becomes y is equal to negative 8x plus 60, and we could divide each term by 4. Right? So everything that was there before it, we're going to divide it by 4. So y is equal to 4 could go into 8 2 times. So that's negative 2x plus 4 could go into 60. 15 times. So y in terms of x, anytime you have something in terms of another, it means that the one that is before will be the subject of the formula. And when I say in terms of, that is after the phrase in terms of, that will be on the other side. All right, so it says part B, the area of the rectangular seatbelt is equal to the area of the square seatbelt. So remember, we have two seatbelts, one rectangular in shape, one square in shape. They said the area. So this one was 3x and x. And this one, remember, is y as a side. So they said the area of a rectangle. So you have to know how to solve the area of your shapes as well as the parameter. So area is length by breadth or length by width. So that will be 3x times x, which will be 3x squared. Right? Because anytime you have a letter, I select 3x multiplied by x. Anytime you have letters multiply, and they are the same, x by x becomes x squared. Right? So it will be 3x squared for the area of that one. And then for y, the area of the square. The area of a square is side by side. So that will be y by y, which is y squared. Right. So they said the area of this region is equal to the area of this. So we have the area of the rectangular one is 3x squared is equal to y squared. Now, this is taking us into the topic of simultaneous equations. A simultaneous equation is basically an equation where you have two unknowns to find at the same time in one question. Right? Now, from this, we have two unknowns. Right? So there are two unknowns, and we call those unknowns variables. We do not know what are the values of y and x. So we may find that we don't know that, but we have two equations. We do have two equations because we have the first equation that we came up with was that y was equal to negative 2x plus 15. So this is one equation. And then this is another equation that we came up from it, which is y squared is equal to 3x squared. I just flipped it around so the y's will be on the same side. So we have here a simultaneous equation. Now, there are different ways to solve a simultaneous equation. First things first, the first way is by elimination. Then we have substitution, and then you have the graph. For this one, I'm going to do the substitution. As we go along and practice, we'll get the hang of each of them. So for this one, we're going to substitute. So what does it say? It says y is equal to this. Y squared is equal to this. It says use this information and your answer in A. This was the answer in A. to write down a quadratic equation in terms of x and show that it simplifies to this. So they actually gave us what they want. So this is the answer we want, but they want to see if you know how to bring it to this. In substituting, remember substitution is that you're replacing one thing with another. So if I know that y is equal to this, so what this is telling me is that y is negative 2x plus 15. So what we can do is we could substitute y is negative 2x plus 15 into equation 2. Right? So you're going to substitute here. So you see where you have y here. We know that y is negative 2x plus 15. So we're going to replace y. So instead of having y there, I'm going to put what y is. So instead of having y here, I'll put that y is 2x plus 15 squared. Because remember, this was y, but we substituted what it is instead. Is equal to 3x squared. Right, so we end up with this expression. It's all of this is being squared. So I'm putting it into brackets. Is equal to 3x squared. So it means that everything inside of this bracket will be squared. Now, this means negative 2x plus 15 will be multiplied by itself, which is negative 2x plus 15. So we're going to expand, right? In order to get rid of brackets, you multiply whatever is outside by everything inside, which means everything inside of here has to be multiplied by everything inside of here. We could use our calculators to help us. So we have this. So each term in this one, we're going to multiply by everything in this one. So this will become negative 2x multiplied by negative 2x. X times x will be x squared. And negative 2 by negative 2. Remember, you multiply like normal, so 2 2's are 4. And because we have two same signs, the answer will be positive. And then we're going to multiply negative 2x by 15. Negative 2 by 15, multiply like normal, 15 times 2, that's 30. But because there are two different signs, it becomes negative 30x. So we multiplied that first term by everything in the brackets. And then we're going to multiply this one by everything in the other brackets. This is known as expansion or expanding. So we're going to multiply the second term by everything in the second. So 15 times negative 2x. Again, that will be negative 30x. And then 15 by 15. 15 times 15, I'm using my calculator here. and I got 225. Right, so remember we expanded the left-hand side of the bracket, but we also have it equal to the right-hand side, which is 3x squared. Algebra likes organization. So you see how you have x's here. It loves us to simplify it. So we're going to add them because we have two same signs. The rule is when you have two same signs, we add like normal and we keep the sign. So keeping the sign, we're going to add 30 plus 30, that's 60x, plus 225 is equal to 3x squared. Now they want it with 0 on one side, which means they want this. They don't want anything on this side. So we had to bring it across. And once you cross the equal sign, you do the opposite operation. So because it was adding there, it's going to come across and it becomes minusing. So I have this is in terms of x squared. When it comes over, I'm going to put it next to the next one in x squared. Right? So I'm going to bring it across. So it was added. So when it comes across, it becomes minus. Right? Because remember, we didn't want anything on the right-hand side. We wanted 0. So 4x squared minus 4x squared, you add it like if x squared is mangoes. So let's pretend x squared is mangoes. So I have 4 mangoes. Take away 3 mangoes. That will be 1 mango or 1x squared. So we have 1x squared here minus 60x plus 225 is equal to 0. And that's what we wanted to show. All right, so the second part, it says solve this quadratic using the quadratic formula. Now, I'm not working this one tonight, so that will be on my next session. However, there are 4 ways to solve a quadratic. A quadratic, you could factorize it and then solve it. The first way is that you could factorize it, which is what we were doing. Remember, quadratic is in the form of ax squared plus bx plus c. So we could factorize and then solve it. Now, let's do that one. So let's say we had something to factorize. And when we factorize it, we know that we end up with something like this. Right? So we know when we factorize, we're going to end up with something like this. Right? So the end result of factorizing a quadratic gives us two brackets with terms inside of it like anytime you are asked to solve after you factorize, what you can do is you put it equal to 0. Now, it's either, so anytime you multiply by 0, we know our answer is 0. So let's say the first number was 0. If I multiply by another number, it will be 0. If it is that my second number was 0, when I multiply by my first number, I get 0. So anything multiplied by 0 is 0. So with this fact being made here, this means that either this is equal to 0 or this is equal to 0. So what we do is we work both of them. So anytime you're factorizing and you ask you to solve it, you either say the first bracket equal to 0 or the second bracket equal to 0, and then you solve for the latter. So t carry across everything else, it becomes 0 minus 8, which will be minus 8. Or, so you basically just solving each of them. When I carry this across, it was minus, and so become add or bracket 1. This was multiplying, so when it goes across, it becomes dividing. So in a quadratic, we have two solutions. In this case, t is either negative 8 or t, in this case, would be 1/2. Right, so in a quadratic, you have two values of the unknown. So in solving a quadratic, you could either factorize it first, like what we just did, what we were doing earlier. And then if they tell you solve it, you put it equal to 0, and you put each bracket equal to 0 and solve them separately. The second way is known as completing the square, which is something I'll do. The third way is by using the quadratic formula. And then the fourth way is using graphs. Now for this one, it said use the quadratic formula. Now the nice thing about the quadratic formula is that they give us it in our formula sheet. I, however, recommend that you learn it still. Right? I recommend that you learn it still. But they do give us it in the formula sheet. And it's this one here. Right? So the part where they say roots of a quadratic, the roots of a quadratic is like the answers for the quadratic sum. So we could use this as a formula, and we just basically substitute from the quadratic. Wherever I have B, I put B. Wherever I have C, I put C. And wherever I have A, I substitute A and Z. Right? So next class, we're going to use the formula to solve that one. But for now, if you want and you want to try it, or if you've done it before, you could use the formula, which is this one. They normally give us certain formula sheet at the beginning of the exam paper, but I still recommend you know it because it will take you time to flip back to get it. Right? So if it is that you've done it before, you could try the question and see. And what I'll do is in our next session, we'll work it out.